Okay, so there are three laws which are associated with logarithms. Now you remember, all logarithms is they're just another way of thinking about powers. Namely, it's saying, well, what if we didn't know what that power was? Like 2 to the power of something equals 16, we didn't know what that power was, it's just a way of rewriting it. And of course, with powers, with indices, there are these things called laws of indices. It was the second thing we ever did. There's laws to do with indices, so it makes sense there should be laws to do with logarithms as well, right? Okay. So I'm going to give you them. There's only 3, okay? I'll talk you through where they come from because it's literally just a bit of a reminder of indices, okay? And I'll always show you where they come from, just purely because if you're sitting in an exam and you're like, oh, I can't remember it, then you can always have a go at rederiving it for yourself. I'll then give you a load of questions and then happy days, we should be okay, all right? So first of all, a good technique when it comes to dealing with logarithms is to be able to rewrite them in indice format, in power format. So if I give you log to the base a of x equals n, could you rewrite that in power format for me? What would it be?
A power of something is equal to x.
So a to the power of what in this case? N. That's the power, yeah?
No.
So a to the power of n is equal to x. Perfect. What about the next one? What if I wanted to rewrite that?
Same thing.
Would it be the same thing?
N power, a power of n equals y.
Yeah, it's the same idea, I agree, but obviously it's different letters, yeah? So this will come in handy. So let's think. What was the first ever law of indices that we looked at?
I wouldn't say.
That's true. Okay. What was the first ever law of indices that we looked at? Can anybody remember? It was this thing. If I gave you 2 to the power of 3 times by 2 to the power of 4, what should that be equal to? 2 to the power of 7. In other words, in general case, if you have the same base, well look, we've got the same base going on here, okay, and you have different powers, you multiply those two things together, that is equivalent to adding those powers together. Now, really, the first law of logarithms is just this law thought at in terms of the powers. In other words, if we add powers, we should be multiplying in the bases. All right? Let's see how this happens. So what I'm going to do is I'm going to take these two logarithms, okay, and I'm just going to combine them. So I'm going to say instead of having log to the base a of x and log to the base a of y, I'm going to say imagine if we had log to the base a of x times y. That's equivalent to what we're doing over here, okay? So log to the base a of x times y, okay. Well, would you be happy that we have two equations for x and for y? Namely, this should be the same as log to the base a of, well, x is just a to the power of n, yeah? And then I'm multiplying that by a to the power of n, yeah, because I'm multiplying by y. So I'm going to multiply that by a to the power of n. Okay, let's think about this. If I'm multiplying the bases, what should I be doing in the powers? Imagine there wasn't a logarithm there. Imagine I just gave you that. So what should that be equal to?
A power of n plus n.
Perfect. So I could say that that is log to the base a of a to the power of n plus n. Would you be happy with that? Yeah? Now let's think about this. Let's think about this. If I say log to the base a of a to the power of n plus n, what should that be equal to?
A power of 2n plus 2n.
Not quite. What this is literally saying, remember the way which you need to think about a logarithm is what power do I need to raise a to get a to the power of n plus n?
N plus n.
N plus n. We all okay with that? If this was log to the base a of a to the power of 2, you're saying what power do I have to raise a to get a to the power of 2? The answer would be 2. Does that make sense? Yeah? Okay. So in other words, this thing is now just equal to n plus m. Well, look, n is just log to the base a of x. And m is just log to the base a of y. So basically what I'm saying there is that if you have log to the base a of x times y, that should be the same as log to the base a of x plus log to the base a of y. That's equivalent to what we're doing over here. Are you happy? You're basically saying if you're multiplying in the bases, you're multiplying here, that should be the same as adding in the powers. You're adding over here. Remember, logarithms are looking in terms of powers. So the thing in here is kind of to do with bases. The thing over here is to do with powers. So can you see the equivalence with law 1 of laws of indices? So that there is your first law of logs. Okay? If you multiply inside the bases, it's the same as adding in the powers. Okay? So log to the base a of x plus log to the base a of y should be the same as log to the base a of x times y. So all right then, what about the second law of logs? Can anybody remember? It's division, right? So if I give you now 2 to the power of 4 divided by 2 to the power of 2, what should that be equal to?
2.
Yeah, it's 2 to the power of 2. You subtract the powers, okay? So let's do a similar kind of thing, but this time instead of multiplying, let's divide. So let's do. Hopefully you can see that, but let's prove it. Let's prove it, okay? So similar kind of thing as before. We replace x with a to the power of n and y with a to the power of n. So we have log to the base a of a to the power of n, that's x, divided by a to the power of n, that's y. And you're dead right. If you divide, so if I just gave you that, you'd say that's a to the power of n minus n. Yeah? So you've got log to the base a of a to the power of n minus n. Okay? What's this thing equal to? It's just n minus m. You're literally saying, what power do I have to raise a to get a to the power of n minus m? That's just n minus m. Well, what is n? It's this thing. And what is m? It's this thing. So can you see the equivalence? Good. Now you notice in this case, it does matter where x and y are. It does matter where x and y are. So x is the numerator, that's the thing you start with. Y is the denominator, that is the thing you're subtracting. But it's exactly equivalent to this. Yeah? If you're dividing in the bases, you should subtract in the powers. Division, subtraction. That's your second law of log. Okay? Can I rub that off? Yeah? Good. So last one then. What's your third law of log? Can anybody remember? Sorry, the third law of indices. Can anybody remember?
Little n?
Not quite, we're not there yet. Yeah, if I give you like 2 to the power 3 and I raise that all to the power 4, what should that be equal to?
2 power of 12.
Yeah, 2 to the power of 12. In other words, you've just multiplied the 3 by the 4. So what I'm literally saying there is if I take a thing which is already the power and then raise that to a power, so I've got a power and I raise it to a power, that should be the same as just multiplying over here. Yeah? So let's see the equivalence there. Let's consider log to the base a of, let's think about this. Let's go x to the power of p. Okay, let's do that one. Let's do that one. Okay. So what's this thing going to be equal to? Well, let's think. What's x going to be equal to? Yeah, good, but why? So let's see. X is equal to a to the power of n. So we have log to the base a of a to the power of n. All of that thing is being raised to the power of p. All of that thing is being raised to the power of p. You happy with that? Okay. Now, if I just gave you that, if I just gave you a to the power of n all raised to the power of p, what should that be equal to? You just multiply them together, exactly the same as what's over here. All right? Now my question is, what is log to the base a of a to the power of np? It's just np. It's exactly the same thought process we were using before. A to the power of what gives me a to the power of np? It's got to be the power np. Okay? And let's think. What was n again?
Log a of x.
Yeah, good. So basically, if I rewrite that, that's just p times by log a to the power of x. I've just rewritten n over on that side. So that should be equal to log to the base a of x to the power of p. Can you see what's happened there?
We just multiply by 0.
Yeah, so basically if you have a logarithm of something which is being raised to a power, you can bring that power down to become a multiplier. That's your third law of log. Okay, third your law of logs. So in general, And I'll write the general 3 laws over here. First law, if you have log of x plus log of y, let's just assume, you notice here I'm not writing any bases, let's assume that the bases are the same. It doesn't matter what those bases are. What should that be equal to?
Log x times y.
Perfect. That's your first one. What's your second one?
Log x minus log y equals log x over y.
Perfect. And what's the third one?
Log x times log y.
Not quite, we've done that one.
Oh,
Log x to some power.
that's not value. So it equals p times log x.
Good, well done. So those there are your 3 laws of logs. Okay, nicely summarised. Any questions about that? No. No? That's all you need to remember.
Are these the only things you took in indices?
Sorry?
Is this only the things that you took in indices?
They're on the VLE, so you can go back and watch those. There's 7 of them in total. Yep. I suppose we could put a couple of extra ones in there. What would this thing be equal to? What's the log to the base a of a?
1.
Just 1. A to the power of what gives me a? It's just 1. What about this one?
0.
It's got to be 0. Anything to the power of what gives me 1? It's got to be 0. Yeah? So there's a couple of extra ones if you want them there as well. Any questions? Okay, good.